Okay, and I think we are live. Are we? Right. Yes, we are live. Hello, everyone, and welcome to our first DevSecCon Greece event of 2025. I'm Spiros Maglis. I'm the founder of Lutsec Cybersecurity and DevSecCon Greece chapter leader. Today, together with me, I have Nikolaos Roumeliotis, who will be sharing an interesting talk on how to save the day with proper input validation. Now, before that, allow me first to quickly share a few things. So, if this is your first time in a DevSecCon event, DevSecCon is a global community powered by SNCC with more than 70 chapters around the world. And the goal of the community is to empower and educate professionals around DevSecOps, application security, and other security domains. Now, if you would like to interact with chapter leaders, the speakers, and other fellow members, Discord is the place to do so. So Discord is a place where we virtually hang out and we share knowledge, tips, and tricks. I will share the Discord link in the chat. So for anyone interested, you are feel free to join. Just before bringing in Nikos, I have an important announcement to make as well. So apart from today's speaker, Nikos, he's also a new addition on the DevSecCon Greece chapter. He's taking the role of the co-lead together with me, and this was a much needed addition to help the chapter move forward and bring more exciting and interesting content to our community. So that's pretty much what I had to share. And without further ado, let me bring Nikos in and let's start the session.
Hello.
Hello, Nikos. How are you?
I'm doing fine. I'm fine.
Nice, man. Allow me first to officially welcome you to the DevSecCon Greece community. Thank you very much for taking the co-lead position together with me, and I'm really excited to see what both of us can actually bring in this community.
Sure, I'm happy too. I can't wait, to be honest.
Nice. So let's not keep the people waiting anymore. And if you are ready, I will bring your presentation to the scene. I will move myself out of the frame, and you can take it in.
Yeah, I'm ready. Let's go.
Okay, let's go, guys.
So, hello everyone, and thank you for being here today. My name is Nikolaos, but you can call me Nico. I'm so excited to talk about how we can actually save the day with proper input validation in Java Spring Boot. A little bit about me. I am an ethical hacker, pen tester, and application security specialist with over 5 years of experience, primarily focused on web application security. I have a strong passion for security, always looking to improve my skills and stay up to date with new technologies. My technical background includes working with various web frameworks and programming languages such as PHP, JavaScript, Python, MySQL, and Java. In addition to software development, a significant part of my work involves code reviews and security assessments, including penetration testing on web and mobile, as well as infrastructure networks. To support my expertise, I hold multiple security certifications. These have helped me develop an in-depth understanding of security vulnerabilities and exploitation techniques. Outside of work, I enjoy participating in CTF challenges to sharpen my hacking skills, and when I'm not breaking things for security, I like to watch movies and series. Now that you know a bit about me, let's dive into today's topic and discuss how proper input validation can prevent critical security vulnerabilities like SQL injection. Alright, now that I have introduced myself, let's talk about what we will be covering in today's presentation. The focus of this session is input validation in Java Spring Boot and why it is crucial for building secure applications. Specifically, We will discuss how improper input validation can leave applications vulnerable to one of the most dangerous security risks, SQL injection. Here's what you can expect from this discussion. First, the importance of proper input validation. We will explore how enforcing strict input validation can prevent these kind of attacks. I will introduce key validation annotations in Spring Boot and explain how they help protect applications. Second, understanding the SQL injection vulnerability. I will explain how applications become vulnerable to SQL injection when they fail to properly validate and sanitize user input. We will look at a real-world example of a vulnerable SQL query and how an attacker can exploit it. And finally, a practical demonstration. I will be showing a hands-on demo of a Java Spring Boot application that is initially vulnerable to SQL injection. Then I will demonstrate proper input validation techniques to fix the vulnerability and make the application more secure. By the end of this session, you will have a clear understanding of how to use proper input validation to secure your applications against SQL injection and other common threats. With that said, let's move on to some important annotations before we dive into the demo. Now, before we dive into the practical aspects, let's go over some key concepts that will help us understand the importance of input validation and how we can apply it effectively in Spring Boot. First, we have the valid annotation. This annotation is used in Spring Boot to trigger Java bean validation when validating an object. It ensures that the fields in a class comply with the defined constraints. Valid annotation ensures that any input violating this rule will be automatically rejected before reaching our business logic. Next, we have validated annotation, which is slightly different from valid. While valid is used for validating objects, validated is applied at the class level to validate method parameters. It is particularly useful when working with request parameters in controllers or service layers. Next, the pattern annotation is a powerful tool for enforcing specific formatting rules on user input using regular expressions. It is often used to validate fields like email addresses, phone numbers, or usernames. For example, if we want to allow only alphanumeric usernames between 5 and 12 characters long, we can use a regex pattern. If a user tries to submit an invalid username, such as one containing special characters, the validation will fail, preventing potential dangerous input from being processed. Next, we have UUID annotation, which ensures that an input string follows the correct UUID format. UUIDs are widely used as a unique database identifiers, and enforcing this format prevents incorrect or untabbed data from being processed. For instance, if a request requires a user ID in UUID format, this annotation will validate that it follows the correct structure. If a malform ID is submitted, Spring Boot will reject it immediately, improving both data integrity and security. Finally, let's talk about one of the most dangerous vulnerabilities, SQL injection. SQL injection happens when an attacker manipulates an application's database queries by inserting malicious SQL statements into input fields. This can lead to unauthorized access, data leaks, or even complete database compromise. For example, if we have a query which takes a user input and concatenates it, an attacker could input a specific payload which modifies the query to always return true, for example, allowing unauthorized access. This is why proper input validation along with parameterized queries is crucial to prevent SQL injections. Now that we have covered the theory behind input validation and SQL injection, it's time to put everything into practice. In this lab session, I will be sharing my screen to walk you through a Java Spring Boot application that initially and intentionally contains an SQL injection vulnerability. We will analyze the issue exploit it to understand the risk, and then implement proper input validation to secure the application. Here are what we will be doing. First, exploring the vulnerable code. I will show you how the application currently processes user input without proper validation. We will execute a simple SQL injection attack to demonstrate how an attacker can manipulate the database. Then, fixing the vulnerability. Next, we will implement proper input validation using Spring Boot annotations. We will modify the code to use prepared statements and parameterize queries to prevent the SQL injection. And at the end, testing the fix. After making the changes, we will test the application again to ensure the vulnerability is no longer exploitable. And by the end of this lab, you will see firsthand how small mistakes in input validation can lead to serious security risks, and more importantly, how to fix them effectively. Okay, let's get started. All right, here we are in a very secure environment where we can see the actual code of the application. I have here opened the VS Code, and we can here browse all the files of the application. Starting with this class, where the application it's triggered to get started. So I have already done it. So let me explain a little bit how I usually do secure code reviews. Since the application has endpoints and we expect from those endpoints to have some interaction with the end users, we usually look for the controllers first to figure out and find out where the user provides the input. So the first thing you need to check is to go to the controllers to find the endpoints, identify all endpoints, and then check all the parameters. Let's go to the product controller and have some look of the endpoints. At the top, we see all the imports. We have some specific annotations to specify that it is a REST controller. I intentionally put some annotation for cross-origin just to make this demo efficient and work without any other interactions. I have specified here my request mapping with the actual path of the endpoint. Some properties defined, some logger to see what happened, and here comes all the endpoints. So we have the first endpoint with its GET request, which as long as I can see, it says that users all. So we expect to return all the users. Next, we have another one where we can see all the application, all the products of the application here. Next one, it's another one, a GET request, which takes an ID and then returns a specific product by ID. We have multiple endpoints here, so we will not cover all of them. We will focus on specific endpoints, but here how it goes. So let's dive in a little bit in the method for the GET request, which takes an ID as a parameter. As you can see, as we selecting it, we can follow the variable, what it does to our logic here. So in order to test that this endpoint works, let's check it out by calling it. I have here some collection to trigger the endpoints. So here we have the products all. If we send the request, we see that it works and it returns back two products. For the product single, we have a specific GET request, which actually takes an argument, a number, to return back product according to ID. So if we send this request, we can see that we get back the product. And if we go back to all products, we see we have only two. And if we change the parameter to number 2, we can see the second product. Okay, now we make sure that the endpoints work. Let's complete our code review. So here, as we can see, takes one path parameter, a path variable, which it's an ID. The first thing that the method does, it logs it, and then with a try catch function, we can see that it goes to a specific repository with the find by ID method and then returns back a JSON response. Okay, let's follow a little bit and find out the product repository, what it does. If we go to our files, find the repositories, we have here the product repository, which contains all the code. And of course, we have the product repository, which is the interface for that. So we can define here some methods. Okay, let's find the find by ID method. This is the one. So here is the find by ID. It takes a parameter ID as a string. And as we can clearly see, the same parameter here goes directly to the object, to the query object for that. And as we can see, and as we talked a bit before, it does an concatenation here, so directly access the query. So we have a potential issue here. We can see that the ID goes directly to the query and probably gonna cause problems. In order to test our thoughts, because first we can clearly see that the parameter goes directly to the query, let's test it through the endpoint. Let's go back to the endpoints. We find the endpoint with the products. So let's check the first one again. So it returns back. So the most common technique to identify an SQL injection, it's actually to try to close the query by putting a single code in the parameter. So when it goes directly to the query, it can close the query and probably can prevent it, can cause an error. So let me do that. So if we put a single quote and send the request, we can see that we get an error, and probably it's something with an SQL exception, which, as we can see here, tries to close the query and returns an error. So this is a first hint that we can understand that here we have probably an SQL injection. We have already identified it in the code, but here it's a clear example that we actually do. And in order to verify it a little bit more, let's do another trick here in the URL. So by putting a single code, we try to close the query. And since there is another single code in the actual query, that's why it returns an error. So if I'm gonna say I'm closing the query and then I'm gonna ask to put something which is supposed to be true, right? So we try to continue the query in order to execute it properly now. If I send this one, I can see that I get the object back, which means that after closing the query, I just put the end word, which in SQL, it means that we connect a query to another. And I just put a true statement, which 1 equals 1, and then the dashes here or the hyphens are to close and stop the query there. So now we see that after closing the query and putting a true statement, we see that the query at the end is correct. And that's why it returns back the result. And if we want to test it a little bit more, I have to change this to a false statement, which probably gonna return an error now, as it does. So when the query is correct and have a true statement, it returns the actual result. And when it's a false one, it returns an error. For the case, it's a 404. And this is what I have specified in the exceptions. I have implemented a very simple exception in order to make things easier. So now we know for sure that our rejection point here is there, right? And we identify it by manipulate that query and make it false and true to see the results. All right, let me explain some other thing now. Most of the SQL injections now, we can turn them, we have multiple types of SQL injection. We have the union one, we have the Boolean based, we have time-based SQL injection types. But for every SQL injection, we can turn them to a Boolean SQL injection, which means if the result is true, it means that we have done something correct. So we didn't manipulate the query to return an error. And when it turns false, when it's false and returns an error, it means that the query is incorrect. To automate a little bit the process, I have developed a script here to do that exact thing, to try to exfiltrate data from the database by using true and false requests to see when the query is correct, to return something back, and when it's false, to not return anything. If you are familiar with Boolean-based SQL injection, you can actually test ASCII characters and to find out if they exist. So if the ASCII character exists, it will return a true statement back, so it will return true. But if the character doesn't exist, it will return a false, so we don't get a result. So I crafted a specific here exploit written in Python, which does exactly that thing. So here's my script, and as an argument takes the whole endpoint of the application. So if I run this script, I have scripted everything in Python to make sure that I will check every character to exfiltrate some data from the database. In this case, I'm trying to exfiltrate the password. But before show you that, let me show you something else first. We have another endpoint here, which is the user roles. And if I send this one, I will see that there is one user in the database, which is admin, and has some details here. So we know that there is a user, and we know that this user contains details there. So probably it contains a password, right? But we couldn't see here the password. So I'm expecting, we can verify this, of course, if you go to the code and try to find some other resources. For example, in order to make this application work properly, I have specified some data SQL file, which actually what it does, it inserts automatically when the application starts some data in the database. So as you can see here, we have at the very bottom of the file, we have the table of users, we have the admin user, the email, and the password, which has formatted in MD5. So we know for sure that there is a code there because we have only one user. So expecting that, I have specified this script to find out the password and return back to us. And again, because we have turned this SQL injection to a Boolean based, we have to check each character every time, and if it's true the character, it returns back. And if it's not a character that contains the password, the hash password will not be there. So after I'm running this script, as you can see, the script works perfectly and has exfiltrated the password, which is the same password as we saw in the database file. So now we know for sure that the application is vulnerable to SQL injection, and we have already exploited by exfiltrating the most important part of the database, which is the passwords. Of course, if we change the script, we can exfiltrate any other data from the database. But attackers only look for those kind of details, passwords, emails, whatever is useful for make the impact bigger. All right, so now we know where the vulnerability is. We have identified it. We have exploited it to figure out that there is a risk there. Let's see how we can prevent this vulnerability from happening. In my presentation slides, I mentioned a lot of annotations to have to consider here. So let's go and try to put them in practice. So let's see. For the GET request here, as you can see, we see that it takes one parameter with this ID and directly put it to this method, right? So the goal of this presentation is actually to try to fix the vulnerability with proper input validation and not touching the actual SQL vulnerability. So let me show you again. So here in our methods, we have the find by ID method, which can see that takes the ID directly in the query. So we will leave this as it is for now, and we will try to solve this vulnerability only by doing proper input validation for that. And of course, later we will fix that. Don't worry, we will get there. But yeah, first the first approach is to find out and stop the vulnerability from even processing unwanted data. So we will leave it vulnerable here, and we will see how to fix it from the controller side. In order to save some time, of course, I have already implemented the fix. So as you can see, there is another controller here, which is the fixed controller, which already have implemented all the validations. But let's remember a little bit the slides, how we can do it again. So we can use, of course, the annotations, the pre-built ones for the Java in Spring Boot, but sometimes it requires some, let's say, some other libraries to import. So if we go down here to our files and see the POM file where all the libraries are there, so you can see that we specify specific libraries for that. So these some default ones. We have the Spring Boot start validation, and we have this one as well for the JPA data, which helps us actually validate more things. I will explain a little bit later. We have some database libraries and our database SQLite and some other things. We have also the project Lombok, which is a very known Java library. Most of the Java developers, they already know it about it, and some other things to help this application work. So sometimes when a library is not available in the pre-built Java libraries, we need to import some of them. So we will get there maybe later. But it's a good time to mention sometimes, because sometimes not all the libraries are built in there, but we can figure out how to implement them. So let's continue with that. So here again, as we said, it's the vulnerable method, and let's open and see how we can see the fixed one. So according to our slides, we can use the pattern annotation. The pattern annotation, actually, we can specify regular expressions and then say, okay, this is my property, my variable, and I want only a certain things to be allowed for this one. So let's see the code. As you can see, it's the same one with the same name. And what it does, we actually just add an annotation of the pattern, and if we go at the top, we can see that this comes from the Jakarta library, which is the validation class under constraints and the pattern, where this library came from. So after putting the annotation here, we can specify that we can give the property a specific regex format. For this case, because we are handling numbers, a simple code and a simple regex actually can prevent this. So here we have said that this parameter here ID, it can only takes numbers from 0 to 9. Actually, numbers, that's a range one. And if it doesn't get those kind of ranges, we have a message to return back that the ID is invalid. So with this single one annotation, we have actually validate the ID. In order this to work, we need other things as well to do. So for example, if you remember the slides, we have to specify another class. So, and as we said, that validated class is a class level. So we specify this validated class at the top of our controller instead of putting directly on the properties here. If we want only this one to be validated, we can put it in the method. But as we worked collectively, we want for all the class for this controller to be validated, right? This is gonna help us to return back the message, because if we miss to add this annotation here, we will stop, of course, the vulnerability, but we will not get back the message back for the end users to see, or for the front end. Okay, let's see now with only one line of code here and some annotation, so two annotations in general. Let's see now if this is still exploitable. We're gonna go again to our endpoints. We will check the fixed endpoints. we will open, let me close this one. We will open the fixed endpoint this time. We will send it. We see that it works. And let's repeat again the same technique. If we try to manipulate again, but actually, let me back up a little bit and go back to show you that the repository for that, it's exactly the same, or it's supposed to be. Here is the fixed for the interface. Actually, I have already fixed it, but it's okay. We can see that it will work at the end. So if we put a single code here and set again the, this is the vulnerable endpoint. We want, no, it's the correct one. It's the fixed one. All right. So if I put a single code here and send now the request, I see that I get an error, of course. 500 this time, doesn't matter. But we get that we have an invalid ID format, which says that our pattern works because it returns the error message that we have specified, right? Let's go back to see the method. As we can see, we have an invalid ID format because the user input now try to process a character that we haven't allowed here to be processed. So we accept only numbers. So with this simple trick, we have stopped the exploitation before the ID parameter is being processed to our business logic. And in order to make that sure that the vulnerability has stopped there, we will run again the script with a fixed endpoint this time and see what the results are gonna be. Let's see. So it took some time in order to figure out if you could exfiltrate any character, but at the end, it couldn't exfiltrate anything. So the result of the script returns not exploitable. And if I'm gonna run again the vulnerable endpoint, we see that we get the password, but if we run the fixed endpoint, tries, and then nope, not exploitable. And of course, I have already fixed the SQL vulnerability here from the beginning, I mean in the query, but as you can see, doesn't go to this process before it stops directly before even process the actually variable. So with this technique, with input validation, we stop the vulnerability, even though the vulnerability might exist in our repositories or services. So if we want to save the day, as the title says, because I can understand, I have a development background, and I can see how difficult sometimes is to fix big vulnerabilities or try to implement correct methods or stuff. So by this technique here, by providing proper validation, you can clearly see that we stop the vulnerability from even started. So, and that it's not only about SQL injection, because the mother of all vulnerabilities, if I'm allowed to say like this, it's the input validation. Everything starts from there. So if we properly validate our input fields, we prevent every vulnerability. So with that being said, let's see something else as well. Let's go to the actual code here, the vulnerable one. And okay, I can understand. By providing input validation, it's the first step, right? But that's not at the end of security, right? At the end, we need still to fix that vulnerability, or at least to make sure that we do some we do all the best practices to avoid them from even happening again. So let's try to do it. How to fix that? So as you can see, the method here takes the ID directly to the query, which is not a recommended way, right? Because we saw how it can be exploited. So the fix for that, if we are using the JPC template, which comes with a JPA library, which is here to help us make better code by having an already implemented library for doing what we need to do, for example, to find a product or a record from database by ID. So instead of leaving like this here, we can just remove this, right? because we don't want to have it directly in our query, and we need to make it parameterized. In order to do that, with the JBC template, with the query for objects, there is another easy way to do it. So we're gonna put a question mark here, which is actually make sure that this ID will come from a variable property, from a parameterized property, which we can specify next to the SQL statement here. So if I put here the ID, I make sure that this ID comes as a parameterized query here. And the difference is that the parameterized queries and the variables that can inject here, it takes the value of the parameterized query from the variable and makes it parameterized. So it takes the value only and look at it as a value, but cannot interact with the query because we don't intentionally directly inject it through the query. So if I run this again, if I save it, but as you can see, we are working on the unfixed method. Let's see again this one. So let's delete a little bit for this now. Let's see if it still works. So it does. So whatever we did here, we make sure that the method still works, right? But let's see again what we can see. If I put again a single code and try to run it, we get the same error again, right? Let's see what we did wrong here. Yeah, that's a bit weird. Let us check again what we did wrong. So in our controller here, we have it, the parameter here, takes this in the repository, find by ID. Oh, maybe I should rerun it again. Okay, phew. Now it works. Now it doesn't return an SQL error because the SQL query there, it takes the parameter as not as candidate, but as a value. So it doesn't work. Let's check it also. Let us see if it still works. Okay, it works. And if we try to run this again, this is the vulnerable endpoint. We see that it's not exploitable. But now we fix it in the SQL injection from the method, not from the validation. But it's exactly the same thing. We can do both actually fixes. But the purpose of this presentation is to show you that you can fix the problem with input validation, and then when you still have time, you can update the queries and make the method correctly. So basically, this is it. We have just proven that by providing input validation for the queries, we can stop the vulnerability from even get started. And that's our purpose for this presentation, to show that how important is to put and create proper input validations. But in the sake of this demonstration, let's see something else as well, because we talk only about for the get request, but we can also do same things for the post request. So here, as you can see, we have a post request which actually saves new products and to create new products. And actually, it's a request body and takes here the details from the model. Let's go to check the model a little bit. So here is our model. The models here in Java and specifically in all MVC frameworks works like the communication through the database. So MVC stands for model, view, and controller. And since Spring Boot is an MVC framework, we need to specify our model here. So as you can see here, it's a very simple model. And what it takes here, it's the class products, and we have the ID, name, and description. But as you can see here, we have specified the types for this one. So the type, it's just a string, which most of the times it's the most common way to go with, right? But it's not pretty secure always. If we are talking about a single ID, a numeric one, we can change this to something else in order to fix it. So let's check the product fixed here, as I have already created the fixed model for that. And as we did with the controllers, we specify patterns for our properties. We can do the same thing in the model. So here you can see that I have specified the pattern annotation, which comes from the same library, and I can do the same thing. So it's exactly the same pattern. Instead of using it in the GET request, we are using it in the model for post and put and other methods. So by doing this one, we make sure that every post request or any other request which takes, where it is? Here it is. We takes request body. This is the update one, and this is the save one. Every method that takes request body, we usually call the model for that, right? But in order to make it work properly, let's check again the fixed controller. Let's put them side by side. Go here and scroll down to the save method. We can see that it requires the valid annotation, which we said that the valid makes sure to triggers the method to validate the request. So we have specified here the valid method, the valid annotation in our method, and we have go back to the models, to our model, and say, okay, the valid annotation triggers the validation process, and according to our patterns, we can check if the ID for this example property is been validating with the correct regex and returns an error if this is so. So basically, this is it in general. It's a very simple way to do it. Of course, I can understand that there are probably other ways to fix and do some proper validations. One other one is to create some enumeration classes where actually you can specify and predefine which values you expect. And then if it's something not much with your predefined values, it's been rejected again. But the key for this presentation is how to properly use the valid annotation for post request mostly and put request when it requires a request body. And then at the top here, the validated one, which is for the entire class validation in order to trigger the Java bin validation. So this is pretty much. We need to make sure that we have understand those annotations, and in our methods here we have properly provided. So as you can see, with just a simple, let's say, one line code, we have stopped the vulnerability there. All right, let me see if I have anything else to show you. I think we have covered mostly what we have to do. We have fixed the vulnerability here. Let's check it again. This is the old one. It's not fixed one. Let's see this one. Again, if we run it endpoint, it works. If we try to manipulate it with a single code to break the query, we can see that it returns an error and stop the process right there without processing anything else. Okay, I think that was it, folks. Yeah. If you have any questions, anything that you would like to ask about it, or something maybe it's not properly explained, I'm here and I would love to answer you any of your questions. But yeah, that was it.
Nice one, Nikos. I think so. Something that we're facing every day, especially in security, and one of the most common problems is indeed input validation. As we also mentioned, is the mother of most problems. And just by, if I'm allowed to call it like this, just by this little hack or cheat, if you like, in the controller, you can prevent from the SQL from being exploitable, right? Of course, the right way to do it is you go into your model and make your SQL statement a prepared statement with parameterized queries. But for those who work in a big organizations, they have to deploy, I don't know, 1,000 changes per day. Sometimes it's a little bit tough to do big changes, especially in something that's already in production. So this way, at least you can prevent from bad things happening.
Exactly. And
Right.
of course, that's happens when we have, okay, for now, for our example here, we can see that we have a small application, right, with a few properties and with a very small business logic, right, and only one query that we needed to manipulate or fix. Imagine that some big applications, right, they have a lot of queries to handle. So this is
Correct.
a way, of course, it's not a 100% solution, right? We don't prevent actually to the application to be insecure, right? It will still be, but there we will stop the exploitation and we have plenty of time later to figure out how we can fix our actual vulnerability. So that's why we called this session as Save the Day, because literally speaking, you can actually save the day by just putting proper input validation. And even though you have problems in your repositories or in your services, right, you can still have time to fix them. So I think that's why I wanted to present this today, because it can save the day exactly as it is.
It's true. It's true. It can buy you time to fix it properly. That's indeed true. And something else that it may be also important, you know, not all, without want to be offend anyone, but not all the seniority levels know how to do a proper SQL statement, or how to build a proper SQL statement, right? Of course, even we as juniors, we're making those mistakes. So just by understanding how you can use annotations, because nowadays every framework has some kind of annotation to do the same job as you just show us. Even a less knowledgeable developer or a junior developer can go in and just buy you time to come in and fix it properly, especially if, as I said previously, if those problems exist in production.
Exactly. And another thing I would like to mention, here we covered only for the Spring Boot framework, right? but it belongs to the family of MVC frameworks. So this could be applied in any language, in a
Correct.
Django, in a Laravel for PHP, or in Django Python. So every library, every big framework has a same or similar way to do the same thing, right? Even if it's not with the same words, for example, if it's not a pattern, it's something similar to this. So this could be applied to any language, to any framework. This is the technique that we cover here, that we show that with these methods, we can actually prevent and make sure that we have proper validations.
Correct. I think the important takeaway from this is even though your model is vulnerable, you can prevent the exploitation by properly validate and controlling the user input. I think that's the key takeaway from this session.
Exactly.
It's not the way to solve it. It's just buying you time, right? Let's be honest. And I think we are completely clear on that. But also, as you mentioned, yeah, indeed, all frameworks nowadays, they use some kind of annotation to do the same things. So it's just matter of reading the documentation, finding the right library, the annotation, and put it there and control the user input.
Yeah, exactly. For the frameworks, of course, there are come this pre-built, or you can use a library to use it. But let's a bit discuss when someone wants to create an application in a pure code. For example, using just pure PHP. In order to do that, you need to create a function or a method by your own, which does the same thing, right? Takes a string and say, okay, checking the string, and okay, I can create a whitelist because we prefer to make a whitelist, not blacklist. And let me explain a little bit. Blacklist sometimes can be bypassed, right? You can bypass a character if it's in a blacklist, but in a whitelist, you make sure that only that character is allowed to be processed. So if you are willing to create an application in a pure actually language, for example, the PHP one, you need to do it that manually, and that takes more time, of course. There is an open window for making mistakes. Yeah, it's totally understandable. That's why we always recommend for every developer out there to use some kind of framework. And of course, we have now in 2025, we have modern technologies and modern frameworks for every language. So you will find your way there. If you're a Python guy, you will find the Django project to work on, right? Even Flask, if you are, if you are a more simple user, let's say. And of course, let's mention for the PHP one, of course, there is a big one, which is the Laravel framework, which also it's an MVC. So it has also pre-built annotations there to prevent it because it works the same way.
Indeed. Let me say that if in 2025 you are still building production applications in pure language without using a framework, yeah, I don't know what to say. You're probably doing something wrong, without any offense. That's why the frameworks are being created, right? To make our life easier, make it faster, and it's less prone to fail. Of course, at the end of the day, you are relying on someone else's code to prevent or fix your problems, if I can say that. But I believe if from 100 developers, if they're trying to build it in a pure PHP, for example, it will be way less secure than using Laravel, because Laravel, there is huge community behind it. It's been for so many long on out there and used. So many vulnerabilities and issues on the framework have been already discovered, and in the libraries, of course.
Exactly. So yeah, I hope,
Perfect.
I hope we saw something interesting here for the developers, and of course, we enforce and we actually try to, um, to help the community to understand that best practices, writing best and secure code from the beginning, it's what it solves all the problem. So yeah.
That's indeed correct. All right, folks. Thank you for being here. That's pretty much what we had to share with you. Once again, I would like to officially welcome Nikos to the DevSecCon Greece chapter as a co-leader, and we'll be in touch, hopefully soon with another session.
Yes. Thank you so much for having me. And that's just the beginning. And we will see you again, all of you.
All right. Then thank you very much, everyone. Have a good weekend ahead and enjoy. Bye-bye.
Bye.